Hello everyone, and welcome to the AI Research Roundup. I am Alex, your host, and today is May 9th, 2025. We are looking at a research paper from Hugging Face's trending list, published just about 11 days ago on April 28th, titled Agentic Reasoning and Tool Integration for LLMs via Reinforcement Learning. This paper introduces ARTIST, a framework to help large language models overcome limitations of static knowledge. It does this by enabling them to reason like an agent, use external tools, and learn from outcomes through a process called reinforcement learning, allowing models to decide when and how to use tools for complex problem solving. So diving into how ARTIST actually works, Figure 1 here lays out its architecture. We see a task first goes to a policy model. This is the AI component that learns to make decisions. This policy model then performs agentic reasoning, which means it thinks and then decides if, when, and how to use external tools or interact with an environment. After using a tool and getting an output, it produces an answer. This answer then generates a reward signal, feeding back to refine the policy model through reinforcement learning, improving its strategy for future tasks. Alright, building on that policy model, this diagram here really details the ARTIST methodology. We see the policy model initiates these reasoning rollouts. These are iterative cycles where the model performs reasoning, then uses a tool, then observes an output, repeating as needed. The final answer from these rollouts is then evaluated. This evaluation generates rewards, which are then processed to calculate an advantage. This advantage value essentially tells the policy model how effective its sequence of actions was, guiding its learning through outcome-based reinforcement learning, using an algorithm the paper calls GRPO to refine its strategies. Okay, so moving to the results. This table here shows the pass-at-1 accuracy on 4 challenging mathematical reasoning benchmarks. Pass-at-1 accuracy, that is the percentage of problems the model solves correctly on its first attempt. We see various approaches, from base large language models to frontier models like GPT-4o. Crucially, the ARTIST framework, when applied to the Quen models, demonstrates consistently strong performance, often outperforming these other methods, particularly on the more complex AMC and Olympiad benchmarks. This really highlights how its learned strategies through reinforcement learning improve problem solving. Delving deeper into how ARTIST achieves these accuracy improvements, these bar charts compare ARTIST to a base model with tools across several metrics on those same math datasets. We can see ARTIST, shown in the darker blue, consistently achieves a higher average reward score, indicating better overall performance. It also makes more tool calls, especially on the tougher AMC and AM problems, suggesting it is learning to use tools more strategically. Finally, the response length is often longer for ARTIST, hinting at more thorough reasoning steps being taken to arrive at the solution. So that thorough reasoning we saw earlier also pays off in other complex scenarios. This table here shifts focus to multi-turn function calling benchmarks. These are tasks where the AI needs to use tools or call functions in a sequence over several steps to get the job done. Looking at the pass-at-1 accuracy, we see the Quen model with ARTIST significantly outperforms base models and even prompt-based reasoning. For instance, on the Tau Bench airline scenario, ARTIST more than doubles the accuracy, and it also shows strong gains on the challenging BFCLV 3 long context tasks. Alright, this next figure gives us a fantastic peek into how that agentic reasoning, particularly the self-correction, works in practice. We see the model attempting a math problem using Python code. It encounters an error, but then, within these less than think greater than sections, it analyzes the mistake, corrects its Python script, and successfully reruns it. It even double-checks the result before giving the final answer. This iterative process of trying, failing, thinking, and correcting really highlights how the model learns to use tools effectively through reinforcement learning, adapting its approach based on feedback. So that ability to self-correct we just saw really underscores the power of the ARTIST framework. This framework, ARTIST, which stands for Agentic Reasoning and Tool Integration in Self-Improving Transformers, fundamentally changes how large language models tackle complex problems. It uses agentic reasoning, where the model actively decides how to use tools and plan its steps, and reinforcement learning, essentially learning from the success or failure of its actions. The key takeaway is that this approach enables models to solve much harder problems, showing impressive gains. Well, that is all for today's AI Research Roundup. Thanks for tuning in.